Welcome to the introduction of ARC 207J, Site Analysis and Planning, Unit 1. I'm AR Kritika R., Assistant Professor at SED, SERMIST, KTR Campus, and I'll be guiding you through this unit. In this introductory lecture, we will cover the following topics: definitions of plot, site, land, and region. Units of measurement used in surveying. Introduction to surveying. Different methods of surveying and their applications. Surveying instruments and their application. And the need for surveying. A plot is defined as a small piece of land that has been marked or measured for a particular purpose. It's a diagram showing buildings, utility layouts, road positions, and other constructions on a site at a defined scale. Typically, it contains information on retained and proposed buildings, landscape elements, above-ground features and obstructions, major infrastructure routes, property boundaries, setbacks, and rights-of-way. A site is an area of ground on which a town, building, or monument is constructed. It's the place where a structure or group of structures is to be located. A plot of land prepared for or underlying a structure or development. The location of a property is also referred to as the site. Land refers to any part of the Earth's surface not covered by a water body. It's an area of ground with specific boundaries. Land includes all physical elements in the wealth of a nation bestowed by nature, such as climate, environment, fields, forests, minerals, mountains, lakes, streams, seas, and animals. A region is a divisive area generalization. It's a large, usually continuous segment of the Earth's surface or space. It is a large, indefinite portion of the Earth's surface. A region is an area on the Earth's surface marked by certain properties that are homogeneous inside and distinct from outside it. It's a part of the Earth's surface with one or many similar characteristics that make it unique from other areas. Regional geography studies the specific unique characteristics of places related to their culture, economy, topography, climate, politics, and environmental factors, such as their different species of flora and fauna. A unit of measurement is a definite magnitude of a quantity, defined and adopted by convention or by law, that is used as a standard for measurement of the same quantity. The most widely used system of units is the International System of Units, SI. In surveying, the most commonly used units define quantities of length, or distance, area, volume, and horizontal or vertical angles. There are two types of measurements used in building surveys: the metric system and the feet and inches system, also known as the English system. Measuring the land is the integral quantitative element of surveying. The most common measurements followed in India are acres, bighas, bisbas, etc. The basic unit of length in the SI system is the meter. The meter was originally intended to be 1/10,000,000th of the distance from the equator to the North Pole at sea level. It has since been redefined as the distance traveled by light in a vacuum. A meter is equal to 1000 millimeters, 100 centimeters, or 10 decimeters. Multiples of meters include the decameter, 10 meters, hectometer, 100 meters, and kilometer, 1000 meters. The basic units for length or distance measurements in the English system are the inch, foot, yard, and mile. Other units of length also include the rod, furlong, and chain. 1 foot equals 12 inches, 1 yard equals 3 feet, 1 rod equals 5.5 yard, 1 chain equals 4 rods, 1 furlong equals 10 chains, 1 mile equals 8 furlongs. The units of measurement we will cover are length, area, volume, mass, angular measurements, temperature, and pressure. Surveying is the art and science of determining the relative positions of various points on the surface of the Earth by measuring the horizontal and vertical distances, angles, and taking the details of these points, and by preparing a map or plan to any suitable scale. Surveying is the technique and science of accurately determining the terrestrial or three-dimensional space, position of points and the distances and angles between them. To accomplish this, surveyors use elements of geometry, engineering, mathematics, physics, and law. Surveying has been used to mark property boundaries and divide land since the earliest times. Present-day surveys include establishing the property boundaries of private and public lands, preparing navigational charts for use on land, sea, and air, mapping the Earth above and below the mean sea level, collecting data for land use and natural resource management with a view to protecting and preserving the environment, determining the size and shape of the Earth and mapping its gravitational and magnetic fields and preparing astronomical charts showing the locations of the Sun, Moon, planets, stars and other celestial bodies. Good survey work includes the following steps or phases: planning, analysis, and decision-making involves selection of the method of survey, selection of the equipment, location of salient survey stations. Care and adjustment of instruments includes the use of delicate, precise instrument whose care and adjustment require the best attention of the surveyor to ensure the accuracy of the survey. Fieldwork or acquisition of data involves making measurements, recording them in a systematic, sequential manner. Office work, i.e., computing and data processing, consists of making the necessary computations, preparing plans, and maps to a suitable scale. Setting out on the ground is a sort of converse operation to surveying, involving pegging out the structure on the ground. It is the final phase of the surveying before the construction engineer can begin work. Thank you.